Welcome back, students. So in order to find the minimal polynomial, remember we are not interested in eigenvalues at all. So I'm not interested in the characteristic equation, but rather I am interested in characteristic polynomial. So I'll say we have characteristic polynomial of a, okay, as, and it is given as determinant of, now either you can use x notation or lambda, anyone you can choose. So xi minus a is equal to, and this will be equal to determinant of x minus 1, and rest of the entries in the first row will be 0. Over here it will be 0, it will be x 0 0 0 and x. So this will be equal to simply x minus 1 multiplied by x square, as determinant of diagonal matrix is product of diagonal elements, and a characteristic polynomial of b as is given by determinant of xi minus b, which is equal to determinant of x minus 1 0, x minus 1, over here it is 0, it is x, it is 0 0 0 and x. So it is upper triangular matrix, and again the determinant is the product of diagonal elements. So therefore from 1 and 2 you can see that characteristic polynomials of a and b are same. Now the question is whether the minimal polynomials will be same or not, isn't it? So I will say therefore from 1 and 2 we observe that. Now let us think of the minimal polynomials. Okay, so first we'll find the minimal polynomial of a. So I will write here, first we find minimal polynomials of a. So the possibilities of minimal polynomial, as we know the characteristic polynomial is x minus 1 x square, so the possibilities are x minus 1 multiplied by x or x minus 1 multiplied by x square. So firstly we will check whether x minus 1 multiplied by x is a minimal polynomial or not. So therefore I am going to check whether a minus I multiplied by a will be 0 or not. So I'll say, now consider a minus I multiplied by a, which is equal to, and your a matrix is 1 0 0 0 0 0 0 0 0, and from that you are going to subtract I. So minus I is 1 0 0 0 1 0 and 0 0 1, and outside it is a again, that is 1 0 0 0 0 0 and 0 0 0. So which is equal to, so 1 minus 1 is 0 0 0 0 0 minus 1 is minus 1, this is 0, this is 0, this is 0, and 0 minus 1 is again minus 1, and multiplied by 1 0 0 0 0 0 0 0 0. So which is equal to, this will be 0 0 0. What about, yeah, everything will be 0, I guess this is also going to be 0. So yes, so this x minus 1 multiplied by x is annihilating polynomial of matrix A. So therefore I'll say x minus 1 multiplied by x annihilates, therefore x minus 1 multiplied by x annihilates A, and therefore this x minus 1 multiplied by x is a minimal polynomial. Even you can say the also, because minimal polynomial is unique, is a minimal polynomial of A. Okay, I'll call it as sum 3. Now let us find minimal polynomial of B. Okay, so I'll say now we find minimal polynomial of B. The possibilities of minimal polynomial of B are x minus 1 multiplied by x, or it can be x minus 1 multiplied by x square. So first of all we will check whether this x minus 1 multiplied by x is a minimal polynomial or not. A minus I multiplied by A, which is further equal to, so your A matrix in this case is 1 0 1 0 0 0 0 0 0 minus I 1 0 0 0 1 0 0 0 1, and outside it is A again, so 1 0 1 0 0 0 and 0 0 0. So which is further equal to, so if we go on solving, this will be 1 minus 1 is 0, this is going to be 0, 1 minus 0 is 1, this will be 0, this will be minus 1, this will be 0, this is going to be 0, 0, and this is going to be minus 1, 1, 0, 1, 0, 0, 0, 0, 0, 0. Now let us take the product. So this will be equal to this will be 0, this will be 0, this will be 0, next one is 0, 0, 0. Oh, I'm sorry, it should be b over here, right? Yeah, it should be b. So b minus I outside the bracket b. So again we get it is equal to 0. So therefore over here I'll say x minus 1 multiplied by x annihilates b, and therefore this x minus 1 multiplied by x is a minimal polynomial of b. So in this case the characteristic polynomials are same and minimal polynomials are also same. So I give one example for homework. I will give the matrix C, okay, whose characteristic polynomial is again going to be same, x minus 1 multiplied by, that will be homework. So the C matrix is 1 0 0 0 0 1 and 0 0 0. So try to find out the minimal polynomial for this. This is homework. Okay. So the idea is same. You find the characteristic polynomial, you will get it, and the possibilities of minimal polynomial will be same. So first of all you check whether C minus I multiplied by C is 0 or not. If it comes out to be 0, that will be the minimal polynomial. If it comes out to be non-zero, then directly this will be the minimal polynomial. No need of calculating C minus I multiplied by C square. Is that fine? Because this is a characteristic polynomial and we already know that it annihilates the matrix, because we can take the help of the Cayley-Hamilton theorem. Okay, so now we'll move towards next example. We have to find the minimal polynomial of this matrix A. So first of all I'll find the characteristic polynomial. Okay, we have characteristic polynomial of A as this determinant of xi minus a, which is equal to determinant of x minus 1 minus 1 minus 1 minus 1 x minus 1 minus 1 minus 1 minus 1 and x minus 1. And if you solve this determinant, now I will directly write down the answer. Okay, and it comes out to be x minus 3 multiplied by x square. So the calculation part I leave it to you, that can be done. Okay, so what are the, now since I got the characteristic polynomial, what are the possibilities of minimal polynomial? Okay, so I'll say the possibilities of minimal polynomial are, the possibilities are, it can be either x minus 3 multiplied by x or x minus 3 multiplied by x square. So first of all we'll check whether this x minus 3 multiplied by x is a minimal polynomial or not. So I'm going to consider, I'll say now consider A is the matrix, right? So A minus 3i rather, because it is x minus 3 multiplied by x. So A minus 3i multiplied by A, which is equal to, my A matrix is, all the entries are 1 minus, so this is my 3i matrix 0 0 3, and again my A matrix is this. So this is equal to, if you do the calculations, this will be minus 2 1 1 1 minus 2 1 and 1 1 minus 2 multiplied by this 1 1 1 1 1 1 and 1 1 1. So if you go for it, this will be equal to, so minus 2 again 0 I guess. So this is also going to be 0 if we go for the calculations. Yes, so in this case also the minimal polynomial is x minus 3 multiplied by x. So this implies, I'll say x minus 3 multiplied by x annihilates A, and therefore it is the minimal polynomial. So therefore x minus 3 multiplied by x is a minimal polynomial of A. So sometimes it may happen that this comes out to be non-zero. Actually I was looking for that example. Okay, but whenever this comes out to be non-zero, then you can directly say that this is a minimal polynomial. No need of finding A minus 3i multiplied by A square, because that will be satisfied by help of Cayley-Hamilton theorem. So directly also you can say that Since this is non-zero, therefore this x minus 3 multiplied by x square should be the minimal polynomial. So where you are going to face the issues, so you will face issues. Suppose my characteristic poly comes out to be somewhat like this, x minus 1 cube. So in this case, what will be the possibilities of minimal polynomial? There will be x minus 1 or x minus 1 square or x minus 1 cube. So first of all, you check whether this a minus I is equal to 0 or not. Obviously, if a is the matrix, if it comes out to be 0, then this will be a minimal polynomial. Then you go for a minus I whole square. You check whether this is 0 or not. If this comes out to be 0, then this will be the minimal polynomial. But if both are non-zero, then directly you can say that this is the minimal polynomial. No need of calculating this a minus I cube, okay, because it is going to be equal to 0 by Cayley-Hamilton theorem. Okay, so this is what I wanted to tell you. So this is regarding the minimal polynomial. So from the next class onwards, we are going to start with our new unit, that is unit number 3, diagonalization. So we'll stop here.